Hello friends, and welcome to this quick review series. We're going to talk about rational exponents in this video. FYI, I designed this review series just to help you review for something like, say, a math placement exam like ALEKS or something else, but you could also use this as a quick review if you forgot a particular topic in your math class. Sometimes I might mention ALEKS and you can just ignore that if it doesn't apply to you. By the way, for rational exponents, there are some things that you need to be pretty solid on. I'd say that it's important to be solid on fractions, the basic exponent rules, and working with radicals. So if any of these feel like they're kind of a weak spot for you, I do have review videos within this series that are pretty quick on all of these topics. So if you need a refresher, feel free to check those out. Okay, so let's get into it. So here is what a rational exponent looks like. So a rational exponent is referring to an exponent that is a rational number, i.e. a rational number is really a fraction, right? So I have this x to the ab. So how do we interpret this? Well, what's actually going on is that this b is referring to the bth root. So it's for a radical. So the lower part of this is referring to radical notation versus the top part is really referring just to like your I guess your normal, your basic exponent. So, okay, there's actually two different ways in how you can interpret this. So way one is you could interpret this as the bth root of x to the a. And way two is you could interpret this as, let's see, let me write it like this so you can just see it. The bth root of x to the a power. Okay, so you actually want to know both of these forms. So what I'm telling you is that this a is actually interchangeable. You can either do it inside of the radical or you can wait to do it at the end. So it doesn't matter which way you want to do it. A lot of times we write things like this, but we actually want to interpret them like this. So it's actually important for you to realize that these are the same form. Okay, so let's just get used to working with this. So if I had something like 9 to the 1/2, so what is that asking for? Well, since I don't have any number up here, this is really just asking for me to take the square root. So I know that I said that the bottom number corresponds to the nth root, but remember for square roots, there is no number that goes here. When there's a square root, we just assume that there's a 2 there. So this is really just asking for the square root of 9, and so this is going to equal 3. Now, just to give you a second to think about this on your end, I would say maybe just pause the video for like half a second here. Take as much time as you need. Think about what the answer to B and C would be just to make sure that you're getting this. So 8 to the 1/3, that's really asking us to take the cube root of 8, and so that just equals 2. And then C, so this is now really asking you to think about your exponent rules. So negative exponents are telling us to send whatever they're attached to into the opposite position. So this 8, you know, is over like a 1 technically. And so what I'm going to do to get rid of the negative exponent is I'm going to send it into the denominator. This does not make anything negative, right? So a negative exponent is just a set of directions. It does not create negative numbers. And so now this is 1 over 8 to the 1/3, and so that's just going to equal 1/2. Okay, so that is kind of the basics. Now let's make these a little bit more interesting and take a look at 8 to the 2/3. Okay, so you want to do this in the correct manner. So you might think to yourself, oh, this is the cube root of 8 squared. Okay, here's the deal. There is actually a correct way to evaluate this, and I want to show you both ways. So let's compare the cube root of 8 squared versus the cube root of 8 squared. Okay, so in this case, with the way that I've written this, I might be tempted to first take the cube root of, 8 squared. So 8 squared is going to be 64. And then I have to take the cube root of that. Okay, now in this case, that equals 4. But here's the thing. I actually think this is the harder way to go because now you have a much larger number, and the type of number that goes under the radical is really going to matter for this. So the easier way to think about this when we have to evaluate a number is to think about it in this form. So like I said, you have to be kind of flexible and go between the two. I think this tends to be the easier of the two forms, because think about it. If I take the cube root of 8, what is the cube root of 8? The cube root of 8 is 2. What is 2 squared? This is all we have left to do. 2 squared is 4. Cool. I think that this is a little bit of an easier approach than this, and sometimes this can kind of turn into a much harder problem. Okay, so let's do that again. So I've got 25 to the negative 3 halves. So I threw a negative exponent in here just to get us really used to playing around with negative exponents. So this is going to become 1 over 25 to the 3 halves. And now I can actually work with that exponent. So one of the things that we talked about in our exponent video is that you want to get used to just getting rid of the negative exponent so that you're not tempted to turn it into a negative number. So this is the first thing that we want to do. Now I want to actually interpret this exponent. I'm going to give you a second to think about it on your own, and then hit play when you're ready. Okay, so this is actually a really classic case of why we want to evaluate this in the right direction. So if I were just kind of like, oh, whatever, I'm just going to go like this. Okay, so 25 to the third, what is that? Like a lot of people probably wouldn't know that, right? So if I wanted to do 25 to the third first and then take the square root of that, it's just going to be kind of tough. So instead, it would be a lot easier if I took the square root of 25 and then cubed that. Because the square root of 25 I know is 5, and then 5 cubed is going to give me 1 over 125. Okay, cool. So now, moving on to 8, so we're getting right into it. Like I said, you've really got to be strong on your exponents and kind of everything with that. So I want you to think about what is going to be the answer for F here. Strongly recommend you pause and think about it. You'll learn a lot more from this video if you actually try it on your own versus just watching me do it. Okay, so for this one, first of all, this is a negative number, not a negative exponent. This can kind of mess with people's heads. So this is not a set of directions, right? We're just working with a negative number versus since this is a negative exponent, we have to send this into the denominator. So there's a big difference between these two. Okay, so what I'm going to do is I'm going to take the cube root of negative 8, and then I'm going to square that result. Okay, what is the cube root of negative 8? The cube root of negative 8 is negative 2. And this is in parentheses. And I've actually talked about the importance of this case in my order of operations video, so that's another thing that you could go back and review if you wanted to. But since this falls within parentheses, we have to respect the parentheses. And so the way that we're going to interpret this now is negative 2 times negative 2, and a negative times a negative creates a positive. So at the end of the day, the answer here is positive 4. Okay, and by the way, I offer free PDFs of notes on this video, plus all the problems that I go through in the video. In general, I think you're more likely to remember the material if you write it down. So if you'd like a copy of the free PDF, just go to divideandconquermath.com, go to the review section, and then look for this topic, and yeah, you'll be good to go. Okay, so I've got 2 more here. So I want you to pause, give these 2 a try, and let's see how you do. Okay, so for this first one, so I'm going to take the cube root of negative 8, and then I'm going to take that to the 5th power. Okay, so the cube root of negative 8 is still negative 2. And now negative 2 to the 5th, well, when you multiply something negative together an odd number of times, it stays negative. So the answer here is negative 32. So the exponent on top, if we kind of compare this to the previous one, so the previous one ended up positive because I was multiplying something negative together an even number of times. And in the next case, this was negative because I'm multiplying something negative together an odd number of times. Okay, cool. So now let's move on to h here. So now I've got that negative exponent. So the first thing I'm going to do with this negative exponent is I'm actually just going to flip the entire fraction so that I can get rid of the negative exponent. And from here, now what I can do is I can go ahead and take the square root of this whole thing, and then I can cube it. Now, don't panic about taking the square root of a fraction. You literally just take the square root of the top and you take the square root of the bottom. So the square root of 4 is 2, and the square root of 9 is 3. So that's all I'm left with. And then to cube it, you do the same thing. You just cube the top and you cube the bottom. So this will equal 8 over 27. Okay, so that is a brief review of working with rational exponents with numbers. And now I want to talk about how this applies to exponent rules. So just as a quick reminder, these are the basic exponent rules. We've got product rule, the power rule, the quotient rule, and all the different things that you can do with negative exponents. So hopefully you feel like you have a decent grasp on these, or the next part of this is going to be really rough. If you feel like you're really rusty on these, I think it's worth your time to just go back and watch at least a little bit of the review video that I have on this, just so that you're not going in blind here. Okay, so classic rational exponent problems with exponent rules look like this. Okay, so I have x to the 2/3, y to the 1/5, x to the 2/3, and y to the 2/5. So what this is asking us to do, right, since I'm multiplying two things together, I can just add the exponents for anything that has a like base. So for instance, for the x's, this is going to be, let's see, I'll just write it out so that it's clear. So this is going to be 2/3 plus 2/3. And for the y's, this is going to be 1/5 plus 2/5. So this will equal x to the 4/3 and y to the 3/5. Okay, now, I'm not going to lie. For this first one, this is kind of like one of the nicer ones, kind of like the easier ones. Because where these get hard is when you have two fractions that don't have the same denominator. And so this is why I also said, like, you want to be kind of strong on your fractions. If that's a weak spot for you, I think it's worth it just to go back and make that up a little bit. Okay, now let's compare that to b. So I've got x to the 1/4, y to the 2/5, all of that to the 10th. So this is a really clear application of the product rule. We're just doing it with fractions now. So you could always just write out this calculation, right? So ultimately what's happening here, I'm multiplying 10 by these two numbers. So if you want to blow out that calculation, you don't have to shove everything into like these tiny little exponents. So what I'm going to do is I'm going to take 1/4 times 10. Okay, so to multiply 1/4 times 10, let's see, I know that 10 is technically over a 1, so I can rewrite this as 10 over 4, or I can reduce this to 5 over 2. And likewise, for 2/5 times 10, this is going to equal 20 over 5. So again, I just multiply straight across. And so this is going to equal 4. So these are going to be the two exponents then for this problem. So this is going to equal x to the 5 over 2 and y to the 4th. Okay, so where this can start to get kind of interesting is now when you start bringing numbers and variables into the whole problem. So we've discussed how to do both of these things now, and I think this would be a really great moment for you just to pause here and give this a try. Okay, so however you want to set this up, like again, you don't have to just do everything one line to the next. You can kind of blow out the detail if that's what you need. So for instance, if I want to work on 8 to the 2/3, if it's helpful for you, just go ahead and write this out. So this is going to be the cube root of 8 squared, so that's going to be 2 squared, so that's going to equal 4. Okay, so I've got part of the problem. And then, so I need to take 2/3 to each part here. So now I need to multiply 2/3 by the exponents. So I need to take 3 times 2/3. Well, I can see in this case, you know, that 3 is over an invisible 1, so those 3's are going to cancel out, so that's just going to equal 2. And then I'll have 6 times 2/3. So again, that 6 is over an invisible 1. And let's see, there's a couple ways I could go with this. I just canceled out the 6. So this is going to be equal to 4. Okay, so what is my final answer? 4, right? That was from taking 8 to the 2/3. So that was from this work here. And then x squared y to the 4th. Okay, so I've got another one here now, but now it's got a negative exponent with it. So you can see how these kind of just ratchet up in difficulty. So by the way, for the rest of this video, I'm just going to work through increasing levels of difficulty of rational exponent problems. So you know, if you're still trying to brush up on this skill, stay tuned. Otherwise, this is all I'm doing for the rest of this video. So let's keep going with this then. So first things first, I want to get rid of that negative exponent. So I'm going to write this as 1 over 25 x to the 4th y to the 1/3, all of that to the 3/2. Okay, so now I need to evaluate each one of these parts. So 25 to the 3/2, that is going to be the square root of 25, and then I'm going to cube it. So that's going to be 5 cubed at the end of the day, so that's going to equal 125. Now I also need to take 4 times 3/2, so I'll go ahead and do that. So 4 times 3/2 is going to equal, so just multiply straight across, that's going to equal 12 over 2, so that'll equal 6. And then I need to take this 1/3 times this 3/2. So I'll set up that calculation over here as well. And in this case, I notice that the 3's actually just cancel out with one another. So this just equals 1/2. So now I can put all these pieces together. So this is going to be 1 over 125 x to the 6 y to the 1/2. Okay, so continuing on. So like I said, where these problems can kind of turn into real little buggers is when you have different denominators. And so again, don't be afraid to take up space if you need it. If you need space to like do these tiny little calculations, like load them out somewhere else on the paper. Okay, so I certainly recommend that you pause and you try this one totally on your own and then hit play when you're ready. Okay, so I've got x to the negative 1/3 and x to the 1/4. So I need to obviously add these two exponents, but maybe that's a little hard for me to do in my head. So what I'm going to do is I'm just going to write out the calculation and I'll just go through finding my common denominator. Okay, well in this case the common denominator is 12, so I need to multiply this fraction by 4 over 4, and I need to multiply this fraction by 3 over 3. So this is all going to become negative 4 over 12 plus 3 over 12. So this will equal negative 1 over 12. Okay, so this is going to equal x to the negative 1 over 12. Now the good news is that the y's have the same denominator. So 2/7 minus 3/7, that's going to equal y to the negative 1 over 7. But as a rule of thumb, we can't have negative exponents in our final answer. So what I'm going to do is then I'm just going to take both of these variables and I'm going to send both of them to the denominator. And then that problem is done. Okay, so same idea here with f. We actually haven't worked with the quotient rule at all, but it's still the same idea. So in this case, we're going to be subtracting exponents. Also, I've got 15 over 10, so I'm going to actually start by just dividing those by 5, just to make it a little easier to look at. So that's one less thing that I have to do. And then again, it's up to you in terms of how you want to organize all of this information. So I'll show you another way that you could do this. If you're comfortable with fractions, you can go ahead and just rewrite fractions with the common denominator. So this is kind of the way that I think some of my more advanced students do this, like when they get really comfortable with working with these. So for instance, okay, so I've got x to the 2/3 up here and x to the 1/6 down here. So just as an example, so rather than writing this as x to the 2/3, I'm just going to write this as an equivalent denominator with 1/6 so that I can actually figure out what to do with these two exponents. So what I'm going to do is I'm just going to multiply the top and bottom by 2, so this becomes 4 over 12. So 2/3 equals 4, not 12, 6, sorry. 2/3 equals 4/6. So I'm just going to write those on top of one another because then I can really easily see what I need to do with these. And then I'm going to do the same thing. So I've got this y to the negative 1/5. Let's see, let me grab a different color. So I'm going to bring that down. So I've got this y to the 1/5. And I want to rewrite this y to the 3rd as an equivalent fraction with a 5 so that I can figure out what to do with these. So as an equivalent fraction, this will be 15 over 5. 15 over 5 is equal to 3. So if you're comfortable with fractions, this is another great way to do this. And if not, you can still just do the work on the side. I just want to show like different options on how to do this. So, okay, from here, I can see I have more x's on top than on bottom. So I can take 4, 6 minus 1, 6. So this will be 3x to the 3, 6. And then down here, I'm going to have 2y to the 16 over 5. And you'll see, right, 3, 6, this can be reduced farther now. So that's another thing that you have to watch out with these problems. So this will become 3x to the 1/2 over 2y to the 16 over 5. Okay, so I've only got 2 more left in this video. So if you're still here, consider just pausing, giving these last 2 a try, just to see if you're getting it, and then hit play when you're ready. I'll go ahead and jump into it. So 4 to the 5/2. So if I want to shorthand that, I know that I'm going to start by taking the square root of 4. So this is really going to equal 2 to the 5th, right? Because I just assume I take the square root of 4. So this is a shorthand I'm showing you. And 2 to the 5th is going to equal 32. So I can do that on the side. I could also go ahead and multiply these exponents by 5/2. So if I take 1/2 times 5/2, that equals 5 over 4. And if I take 6 times 5/2, that's going to equal 30 over 2, which equals 15. So this is going to equal 32 x to the 5/4, y to the 15th. And for the last one, same idea. So again, just challenge yourself. You can try this one and hit play when you're ready. So I'm going to divide the top and bottom by 2 to get this party started. And then I'm also going to go ahead and just write these fractions with the proper denominator. So instead of writing x squared, I'm going to write this as x to the 10 over 5 so that I can easily compare it with this other x in the denominator. And then for y to the 2/3 versus y to the 1/2, so this requires a common denominator of 6. So I will rewrite this y to the 2/3 as y to the 4/6, and this y to the 1/2 will become y to the 3/6. And now that I can see all of this detail, I can more easily figure out what I need to do. So this will be 2x to the 9 over 5, y to the 1 over 6, all of this over 3. Okay, so just as a reminder, you can't master math just by watching a ton of YouTube videos. You do need to practice it, and I've got you if you need help with that. So each review video that I've made has a companion additional practice problem set. So I'll give you a PDF with problems, an answer key, and then I've also got a video showing you how to work any of the problems. So I would say try this to test yourself on how well you know the topic. So if you're interested in checking that out, go to divideandconquermath.com and check out the review section. And by the way, my review series has many other topics in it. As you can see, I've got fractions, I've got order of operations, I've got everything. So each topic works exactly like this. I've got the refresher video, the practice problems with the answer key, and the worked out solutions. So if you're interested in checking out any more of this series, go to divideandconquermath.com and then just go to the review section and you can find everything there for free. Okay, so I am going to leave it at that. I will talk to you guys in another video, I hope. Bye!